Hi, Year 12s. We'll continue with differential equations and some of the application of anti-differentiation with um, solving a differential equation, but this time you're going to use a definite integral. It's not necessarily anything new, it's just the way its resolution will be a different way. So what you would start with, that's already known. You have your differential equation is a function in terms of x to make things easier. When you solve for y, you anti-differentiate, you get a general integral. What it means is your antiderivative as a function of x plus a constant. That is your general solution. Now what we're going to change is we're going to give a precondition. So for a given point x equals a, that antiderivative y, that integral, will be equal to a value d. If we substitute a and d into that previous equation, we can get the value of c. So c is an expression of d and f of a, which is the antiderivative for x equals a. Another way we can rewrite this is antiderivative of for x minus the antiderivative for a plus d. Now my preferred expression is this one. So y will be the integral. This time I'm going to change, it's going to be in terms of t because the upper boundary is going to be a variable x, but the starting point is we're going to start from x equals a, or t equals a, and we're going to have is plus d, which is the value of the integral for x equals, or t equals a. Alright, so bear in mind I'm going to reuse this formula consistently in those following examples. So here you have your differential equation. Now it's giving you a starting point, x equals 1, then y equal 7. Now you need to find the value of y when x equals 3. So keep this form in mind. So the x equals 1 and y equals 7, that's going to be our a and d, and the x equals 3, that's going to be our upper boundary. So the original method, that's the way you would have done it before doing this exercise. You have dy over dx, you anti-differentiate, you will get a general form. You substitute x equals 1 and y equals 7 to find the value of c, which is here. That gives you the exact form of y, and then you will substitute x equals 3, simplify, and get the value of y. Now with definite integral, I would use this formula. So a and d will be respectively 1 and 7. So I have 1 and 7 here. So integral from starting from 1 plus 7, and the n value will be x equals 3. Now because we substitute 1 and 3 by the value, I don't have an x, I can express the inside integral in terms of x instead of t. You anti-differentiate, that's your definite integral from 1 to 3, and we get the same result. Alright, next one. Read the question. This is the formula that you would need to use, and pause the video to attempt this question. Alright, let's move on. So we have that differential equation. We have our starting point 0, 0. So that will be a equals 0, d equals 0, and the x value will be pi on 4. So we have our integral 0 plus 0. The antiderivative, of course, will be sine from 0 to pi on 4. That gives us sine of pi on 4. Your exact value is root 2 on 2, or 1 over root 2. Last example. This one, you have your f prime you need to find your f value. So it's exactly the same structure. Your f prime represent this function. You want to find f, so you need to anti-differentiate. That's the process. So you will apply the same rule. You know x equals 0, f is equal to 0.5, which is your y, so that's your 0.5 as d. Because it's asking you give your answer correct to 4 decimal places, and you look at the rule, it's a pretty complex rule that you from a first glance you're not able to resolve algebraically, so you would use a CAS calculator. You will type in your function in here. A will be 0 and x will be 1. So your function, which is what you want to find out for x equals 1, so it's the integral from 0 to 1 plus the 0.5 of that x function in terms of t. So just be careful you express at the same variable inside your integral, and you get your answer that you round off. Okay, and that's it for this session. See you.